Okay, so welcome to part 2 of lesson 4.3, Coordinates Computation. So this part is about computing the coordinates or northings and eastings of a closed traverse. So before I will proceed, we will recall the Cartesian plane. So basically, a Cartesian plane uh, is composed of two lines that are perpendicular to each other. We have the x-axis and the y-axis. And the intersection point between these two lines is called the origin. Okay, so in surveying, we describe northings as the y-coordinate, while the x-coordinate is the eastings. Okay, so northings, this is the north-south component, and the eastings, now this is measured along the east-west component. Okay, so suppose I have two perpendicular lines that are that intersected here. So the coordinates is 0, 0, meaning to say x equals 0 and y equals 0. Or in surveying, we have E equals 0 and N equals 0. Okay, so if I will transfer the two lines, those two lines, so the intersection point is at -6, -4, or E is equal to -6, N equals -4. Okay, so same thing here. We have uh, E equals -9, N equals +8. Okay, and then here we have eastings is 9 and northings is 4. No? So the eastings and northings of this intersection point. Okay, so suppose I have a point with coordinates of 10,000 northings, 20,000 eastings. Okay, so take note that in surveying, we usually write as northings, comma, eastings, no? Or that is y coordinate, comma, the x coordinate, no? So unlike in trigonometry wherein we have the xy, in surveying we have yx. Okay, so back here. Okay, so if I will draw a line that passes through that point, okay, so we can say that all points, no, that or all points along this blue line has a y coordinate of 10,000. Okay. Likewise, this orange line or the points along these orange lines has an x coordinate of 20,000. Okay. So, meaning to say, any points below this blue line has a y coordinate of lesser than 10,000. Okay, and then likewise, any points above the blue line has a y coordinate of greater than 10,000 rather. Okay, so same thing for the eastings. Now, all points on the right side of the orange line are expected to have an x coordinate or an eastings of greater than 20,000. Okay, so on the left side, on the left, it is expected that points on the left of this orange line has eastings of lesser than 20,000. Okay, so yun. So we have here northings and eastings. No, our northings of this point is greater than 10,000. Eastings is greater than 20,000 because it is above the blue and then on the right of the orange. Okay, another point below the blue line but on the right of the orange line. So that is northings is lesser than 10,000, eastings is greater than 20,000. Okay, here it is above the blue line, so we need to say the northings is greater than 10,000, and it is on the left of the orange line, then therefore eastings is lesser than 20,000. Okay, we have here it is below the blue line and on the left, so meaning to say northings is lesser than 10,000 and eastings is lesser than 20,000. Okay. Okay, so suppose you have a three-station traverse, okay, with station A having a coordinates of 10,000, 20,000, okay, so you have that, no, A, B, and C, and you are after of getting the coordinates of B and C, okay, giving or given the distances and bearings of traverse lines AB and BC and CA. Okay, so based on the figure, no, we can say that the northings of B is equal to 10,000 plus this amount. Okay, so if you recall our previous lesson, this amount is actually the latitude of AB. Okay, so likewise, if we have the or if we are after of the northings of C, then that would be the northings of B, then minus this amount, which is the latitude of BC. Okay, and then 10,000 actually here is equal to the northings of C, then plus this amount, which is the latitude of CA. Okay, so in other words, the northings of C, okay, so the northings of the last station is actually the northings of the first station, that is the station A, plus the summation of all latitudes, no? Latitude from AB then to BC. Okay? Okay, so for the departure, we have here the 20,000, then plus, no, because it is on the right, plus this green line. The green line is actually the departure of AB. Okay, and then the departure, I mean the northings, I mean the eastings of C is actually equal to the eastings of B, and then minus, no, this amount, the green line, which is actually equal to the departure of BC. No? And then if you subtract the eastings, no, the eastings of C by the departure of CA, it will go back to the 20,000. Okay, so that's why eastings is also equal to, or eastings of C, or eastings of the last station is equal to the eastings of the first station plus the summation of all departures. No, so that is departure AB and the departure BC. Okay, so if you have four stations, so it would be the eastings of D is equal to the eastings of A plus the departures of AB, BC, and CD. Okay, so that's why we have here the rules of computing coordinates. Okay, so it states that for any closed traverse, the coordinates of any stations is determined as follows. For northings, the northings of any point equals the algebraic sum of latitude of lines lying between the point and the reference parallel passing through the point of origin. Okay, so if we recall our previous illustration, we have here the station A having a northings of 10,000 and eastings of 20,000. 20,000. So meaning to say, the line, no, or the origin is somewhere located here, no, or the northings, zero northings is located somewhere below here, no. So here there is a line that is a zero northings, okay, and the distance from this line to point A is actually the latitude of line 0 or line origin to A. Okay, and then if we have another point B, and then we are after to solve the northings, we have to add again the latitude. Okay, so that's why it is it's stated here that it is the algebraic sum of latitude of lines. Okay, so for eastings, we have here the eastings of any point equals the algebraic sum of departures of lines lying between the point and the reference meridian passing through the point of origin. Okay, so back to this illustration, the eastings here is 20,000, meaning to say the line having an easting of 0 is somewhere here, no? Or the real origin, the real origin of this point is actually here. So meaning to say the easting 0 and northing 0 is here. Okay, and then for eastings, no, for eastings, sorry for this. Okay, I cannot draw. Okay, so for eastings, we have here 0, and then that would be plus, no? Plus this amount, okay? Wherein this amount is actually the departure of line origin to A, okay? So that's why uh, if we are after of the eastings of B, we have to add also by this amount, which is the departure of AB. Okay? Kaya yung statement dito, it said that algebraic sum of departure of lines. No? So other term for northings is the total latitude, because it's actually the summation of latitude of lines, and the eastings is also called or known as the total departure because it is the sum of all departures of lines now. Okay, so but before that, no, before solving the coordinates, no, I would like to emphasize that before solving the coordinates of a closed traverse station, it is necessary, no, that you have to balance first the traverse. Meaning to say, you have to ensure that the summation of north and south latitudes, no, are equal, and the summation of east departure and west departures are equal. Okay, so we have here an example. Okay, we will apply those rules by solving this example. Okay, so we have here the adjusted latitude and departures of a closed traverse. Now, so actually the first step in solving the coordinates of a closed traverse is that you have to balance the traverse, but I will no longer discuss on how to balance the traverse because we already did that in the previous lesson. Okay, so the given here are already adjusted. Okay, so as you can see, the sum of north latitude and the sum of south latitudes are equal, no? So you have to sum this up, it will be 0. Algebraically add this one, it will be 0. Likewise, for the departure, the sum of the east departure is this one, and the sum of west departure is this one. So it's equal. So meaning to say this traverse is already balanced. Okay, so we will compute that. Okay, so here Okay, so the assumption here is that station A is at the origin. So meaning to say, uh, your okay, so meaning to say the station A, na, station A is by the way, solving for northings and eastings. We'll solve first for the northings. Okay, so for northings, okay, for northings, okay. So A, it's stated there that it is at the origin, so meaning A is 0, okay, or that is 0.00. And then B, okay, B is equal to the northings of the previous station, no? And then plus the latitude of AB, okay? And that is equal to 0.00 plus latitude AB is 490.71. So it's plus. So therefore, the coordinates of station B is equal to 490.71. Okay. So for C, we also have a that is 490, no? 490.71, or it is actually equal to 0 plus 490.71 because it is just a summation, no? And then plus uh, BC, which is 587.12. It's positive, no? So that is equal to we have 490 0.71 plus 587.12, and then you have 1077.83. And then for D, okay, so that would be 107.83. Then plus, that is D, so that would be CD. Take note, it's plus, then as negative 327.41. So that is equal to 750.42. Okay, so for E, I will no longer show the solution. Okay, we have F. So E therefore is equal to this amount 750.42, and then E, that is DE, it's minus 1002.76, and you have here a negative, no? Negative 252.34, okay? And then you have another that is EF, so it's EF, so it's still negative 122.67, and then you have a negative 375.01. Okay, and then if we add again this one, that is FA, so meaning it will go back to A. It will go back to A. So this is a checking, no? That is a negative, no? 357.01 plus a positive latitude 375.01 is equal to 0. So it is equal. No, it's always since this is balanced, no? So the the northings. No, so when you compute here or when you add the latitudes, it will goes back to 0 now because this is the coordinates of station A or northings of A. Okay, so likewise for the eastings, okay, for eastings we have, okay, for eastings we have A, again it's at origin, so it is 0, then B is equal to 0 plus the departure of AB, okay, take note AB, and then that is equal to 0 plus departure AB is positive 47.27, then that is equal to 47.27. Okay, for C you have 47.27, then that is C. BC, what is BC? It's positive plus 608 or 608.89. Okay, and then you have equal to 656.16. Okay, so D is equal to D is CD. CD is 780. Is it 788? Let me erase. Yeah, it's 786. 786.78, and then you have 1402.94, and then your E is equal to, your F is equal to, so E is equal to 1442.94, and then you have plus, still positive, no? Plus 218.32. You have 1661.26. Then F is, we will use EF, no? So it's minus, so it's plus a negative. You have 1661, oh no, it's 116.62. You have F to be 544.64. Now, so expected, know that A is equal to 544.64. Then the FA, then you have plus, sorry for the, we have, it should be minus, no? Oh, sorry. So DA, so you have, okay, then minus, okay, minus the latitude FA, which is, or that is plus a negative 544.64, okay, and then that is equal to 0. So yun. So check, no? So the eastings of this one, okay, the eastings is 0, no? So when you add, the last latitude should be equal to 0, or it should go back to, the first station. Okay. So this is another example. No, so if you look at, no, the actually this very simple. No, and then it would be much easier for you if you do it in table form. Okay, so another example is we have again another latitude or another adjusted closed traverse. So it is closed traverse because it started with A and then closed with A. Okay, ends with A. So we have the adjusted latitude. So please check on this. This should be 0. Okay, this should be 0 when you sum this up. The adjusted departure, when you add this one, this should be 0. Okay, so in here, you are given the northings and eastings of station A. And then you are asked to fill this up, no? Meaning you have to solve the coordinates of stations B to F. Okay, so in here, uh, that would be 10,000, no? 10,000. And then you have plus the latitude. Okay, then you have that answer. Okay, so next would be 10,490.71, then plus this one, and then you have the 11,077.82. Then further, you have 11,000 or 11,777.82, then plus a negative, so it would be 10,750.41, no? So it's the same procedure, so you can have that one. And then take note, this is station F, no? And then if you continue, okay, this one, then plus this one, it should be equal to, it should go back to 10,000. Okay, so for the eastings, yun, sa eastings naman, you have to do the 20,000, then plus this one, no, the adjusted departure, and then you have this one, no, and then you have that one, and so on and so forth, no. So the last thing, no, please check your work. Now, so the last station, that is F, it is 20,544.65, and if you add the last, now that is FA, it goes back to A, that should be 20,000. Yeah, so it's correct. No? 20,544.65 minus or plus a negative 544.65. Of course, it will go back to 20,000. So meaning to say it's check or your solution is correct. Okay, so that's all about computing the northings and eastings of a traverse stations. Okay, so our next topic would be, or the next part would be the bearing and distance from the coordinates. Okay, how to compute the bearing and distance of a traverse from the coordinates.